32.
Oh, 32?
10.2. Limits and motion. The area problem.
No. Not area.
The area? I'm not going to say anything. I don't want to jinx it.
It's not like, side squared or length times width. It's, it's not that. Area under a curve.
Area under a curve.
Distance from a constant velocity.
This is another movie title.
Huh?
The area problem.
What
Looks
movie
like a
is
movie
that?
title.
No.
Distance
With the in front of
is
it,
equal
sound like a movie title.
to rate times time. All right, so example, computing distance traveled. A car travels at a constant rate of 48 miles per hour for 2 hours and 30 minutes. How far does the car travel?
Oh, for 2 hours? Yeah. At 48, that's not very far.
So, distance is equal to rate times time. So distance traveled is equal to the rate of 48 miles per hour times the time of 2.5 hours gives you a distance of 120 miles. Well, I'm getting ready to make this problem harder, so.
I haven't even written down the problem. I need a second.
Okay, I'll let you catch up. Y'all are slow writers.
I finished writing it down. It's just Josh. Yes, yes.
Okay. Josh is a slow writer, and Jake is a slow writer.
You should even take chemistry class. The course will be like, can I turn the slide now? And Jake's like, 1 more minute.
There was a guy in my class in high school that would be on like line 1 after everyone else was done with like line 5, and she was like, "We're moving on. Get them from online."
Yeah, they're literally online. I hate it when people type the notes and they still somehow aren't one of the first people done.
Okay, now that doesn't make any sense.
That's what I'm saying. It does not.
What do they type like?
Geometry, I would like print them, and then I would just like write like how she would like solve the examples off to the side. But like physical science or chemistry or whatever, I would like actually write them in class.
Yeah.
But I knew if I didn't get something, I could just get it later.
I finished in chemistry like early writing notes just because I don't write everything down.
Yeah, that's true.
Also, like, I usually write down how she explains it instead of like the notes on the board because the notes on the board sometimes don't make any sense.
That's why sometimes if I knew it was going to be like a more like complicated topic, I would like have them printed out and then I would just write like what was said. Because a lot of times, let's be honest, what a teacher says is more important than what's on the slide.
Yeah, or be like, or when Miss Marshall's like, write this down. It's not in the notes.
Yeah, or like her examples instead of the notes example. Because the notes example, she's like, that one's dumb.
Because she didn't make it.
All right, I'm modifying this problem. A car travels at an average rate of 48 miles per hour for 2 hours and 30 minutes. How far does the car travel?
I'm tired of being being sick. Like at the end of the school year too. Like that's so inconvenient.
I know.
Josh is coming up on a year ago from getting really, really sick at the tennis match.
Oh yeah.
That sounds like it sucks.
That was awful.
And then I missed senior night too. So
And cake pops, which is what he was the most disappointed
no,
about.
I was really like I did not.
But I made like a triple batch for the party, so
I
you
know,
can't
so
even complain.
I'm pretty sure I ate like 5 or 6.
And don't worry, I'm making them this weekend,
When is senior night? Monday or Tuesday?
Monday. So I'm glad I have all weekend instead of one night to make them this
Right.
time.
I know.
Almost, yeah.
I feel like y'all just started.
You should come Monday.
Monday? Okay. Oh, wait. Today?
Really? We have
Next
No,
Monday.
like next Monday.
Let me check my schedule.
All right. Distance traveled is delta S. Time interval has length, delta T, and delta S over delta T is average velocity. That's what we saw in the last section. So delta S is equal to delta S divided by delta T times delta T, or 48 miles per hour times 2.5 hours is equal to 120 miles.
Interesting.
In case anyone thought that the answer was going to be different, it is not.
It's just a different way to do it.
So you're gonna ask us to do it both ways?
I could, or when we actually get into examples, it might only be done one way, but
Are these? Is there a lot of notes for this section too?
3 pages. So there were 5 in the last one, so this one's not as bad.
So we should be able to finish these notes today.
Probably. The goal is to do that today, examples tomorrow, workday Wednesday, because I know it's Honor Society, so classes are a little shorter. And then Thursday review, I think, for a quiz on Friday.
When's our honor society practice?
7th period sometime.
Are the notes for 10.1
Tomorrow.
Yes, they're on YouTube.
Oh, tomorrow.
The entire thing should be up
Okay.
there.
I honestly, I didn't even look.
No, that's fine. All right, limits at infinity. When we write the limit as x approaches infinity of f of x is equal to L, we mean that f of x gets arbitrarily close to L as x gets arbitrarily large.
Okay, that's a little bit on the side. That's an 8.
Connection to areas. We graph the velocity function and try to find the area under the curve over some time interval. And if you're like thoroughly confused about what that means, you'll see an example of it in just a second. We will partition. That means break it up into pieces. The area into rectangles to find the area under the curve. All right. This next thing is an example that for me took up an entire page when I wrote down what the example was and then how to like solving it. So if you don't have that that much space, I would say go to a new page. If you want everything together.
I'm out of pages, so I'm just writing my notes underneath my 7.3
Josh got
homework.
a new
You know.
notebook, so he has a lot of space.
Mine's almost running out. This is my second notebook.
What?
That's crazy. Also, random thought, but if at the end of the year, because I would recommend you keep these like notes and examples because it will probably make your life easier next year. If you want to like leave them in my classroom to have for next year, you can. You don't have to by any means, but I can create like a space for you to keep your notebooks so you don't have to worry about them over the summer unless you're gonna study over the summer.
Like
Which-
the calculus notes?
Which I think sounds hilarious, so I'm sure you won't. Yeah.
That was really fun.
Yeah. I'll probably keep them.
Yes.
I don't know. It was just a random thought because I've never gotten this far before, so it's never been a reason to offer it. But
I'm not going to Florida anymore. No, I'm serious.
Where are you going? Wait, what, you're staying in Virginia?
Yes.
Where are you going?
CNU probably.
Why are you
Why
not
not-
going
why
to
aren't you going?
Florida? I thought you already did like a down payment. Wait,
I
not
did.
down
I
payment.
did a $500
Your deposit.
deposit. Yeah, but I mean, I would rather start my life off with like no debt because I can go to any Virginia university for free, or I can start it with $120,000 in debt.
With Starbucks? Because the
No,
Starbucks.
my dad, because my
Oh.
or my mom, it has like 90% disability from like the military or something, so I can go for free. But
Hmm.
yeah,
Well,
so
at least
I will be here, guys. I'll be here.
Hey,
you can come visit.
Yeah, I will. I literally all the time.
please do.
I was like, Riley, I'll be at every game.
There you go.
Most games.
All right. Approximating an area with rectangles. Use the 6 rectangles
Actually,
in the figure below
Maybe I didn't have enough space.
to approximate
Run out already.
Yeah.
We wrote like
the area of the region below the graph
I don't like that word.
of f of x is equal to x squared over the interval,
There's a dog in the hallway.
I should say the closed interval a to b. Okay, this would all be given to you. This is all information that's given to you.
I don't understand any of it, but
I don't think we're supposed to yet.
yeah. Right.
I'm so excited for my chicken minis. That's all I'm thinking about right now.
I
You have
just want
chicken
those chicken
minis?
minis right now.
That sounds great.
Well, Hope and Maddie are just buying everybody chicken minis. Well, everybody's just giving them their money.
Hold up, seriously?
Wait, is it one graph or is it 6?
It's one graph.
Okay, so I'll make one big
I
graph.
haven't drawn a graph in like
A long
know.
time.
a long time. It's been a while.
Like, what's a graph? I don't even know.
The closest I have done is like putting on a calculator.
I don't even know how to do that.
Bro,
If it was from a do it.
What were we doing?
I don't
Exactly.
remember.
Guys, I didn't know Miss Marshall was in here.
She had some unexpected appointment.
Yeah. Apparently she only lets Josh know. I'm not gonna draw.
You're just basically drawing the right side of a parabola
Oh.
at the moment for this particular problem because it's x squared. It's a parent function.
That makes sense.
I was gonna say love that.
All right, now I'm going to do this in a different color just so you can see the boxes because otherwise it'll be kind of hard to see, but oh no, don't undo that. That was not good. That was not good.
I ran away. I said I don't want to do this.
I mean, I don't either, but I'm not gonna run away.
All right, now, when you draw this, okay, what happens is, everybody look for just a second.
Okay.
Okay, you're breaking these into half increments because it's going to be 6 boxes, okay? So the more you have, the more accurate your area is going to be, is what you are going to find. So we're doing 6 boxes in the 3 from 0 to 3. So when you get to where you're going to draw your box, you come up until you hit the graph, then you draw it left and come down. Okay? So it's like, stop.
It did it again.
No.
Doesn't like me today.
It's
Nope.
no matter.
Stop. Okay. So go up, hit the graph, and then come over and you're making rectangles. So it's going to look like this. Like it's going to be a little bit
How do we know
over
where to start the rectangle?
Half increments.
at half. We're doing a
Oh, okay.
six total in the span of 3 spaces. So sometimes, in this case, it was given to you, so you wouldn't actually have had to draw it, but since you're having to draw it on your paper, I'm showing you.
Oh, mine doesn't
My
go up that
rectangles
far.
are gonna be so much bigger than that.
I think I drew the parabola a little wrong.
That's okay. As long as you get the gist of what it's supposed to look like, it's
Yeah.
fine.
I think I get just
Honestly, why is it kind of satisfying to draw this? Like, I don't like this. In a weird way.
weird way.
All right, I'm going to go ahead and finish writing the problem, but I'm going to wait till everybody has it all written down before we go over how to solve it.
Why did I do that?
I thought I drew more than 6 for a second. I was like, no.
1, 2, 3, 4.
And in theory, they're all like, exactly the same width, but obviously you're freehanding
Mine
it,
are a
so
little-
they're not going to be. All right, so the area under the graph of f of x is equal to x squared is approximated by 6 rectangles each with base 1/2. The height of each rectangle. Okay, the base is 1/2 because obviously it's 2 and 1, so that's where the half is coming from. The height of each rectangle is the function at the, now this is important, right hand endpoint of the subinterval. Because we can also do it as a left-handed one, or there's another option, but we don't get that in this book, so no. We're going to keep it simple. As simple as, this can be.
As simple
Right,
as the intro
like-
to calculus can be.
Now I have to take up the calculus 3.
Ew.
What? Really?
There's a third one?
Yes, third's way easier than second. So if you struggle with second, I have a lot of friends that barely got D's in 2. 2 is very hard. Personal opinion. I think it's the easiest is 1, then 3, then 2.
So wait.
And 3 is a lot more like 1 than 2.
Yeah, so CNU's my first option right now. If not, I'll just go to Thomas Hall's. But they only offer computer engineering instead of software engineering. And software engineering is half of computer engineering. because it deals with hardware and software, so I just have to do more stuff.
Yeah.
And they're
I love
it's a
life.
liberal arts college, so you also have to take more
Yeah,
arts classes than you would if you went somewhere else.
yeah, that's fine though. I'm okay with that, but
That's
It's
good.
just-
I was
it's just a
not.
math
I was
thing.
not, which is why I didn't go there.
So they're
Yeah.
minor in music? Is that an option?
I think I'm gonna minor in Chinese studies. I don't know, just something random.
That's so random. I
That
know.
is very random.
No, but I love it.
All right. Does everybody have this down?
Yes.
Okay. We're gonna be drawing a table. Your table is going to be 4 columns. Okay, but your last 2 columns you need a lot more space in than the first 2.
Is this the same problem?
Yes, we're actually getting ready to solve it.
Let's say we haven't done anything.
We've only written the problem so far.
Oh.
And then you're going to have a heading row, and then you're going to have 6 rows because we're going to be looking at each individual rectangle down. So you're going to have 7 rows total, counting the title row, and 4 columns.
I'm just gonna draw it after you draw it.
Okay, that's
Yeah,
that's
probably
fine.
a better idea.
I would.
Yeah.
Guesstimate my space. I love chemistry. Oh, someone just fell. Microeconomics. I don't even know what that means.
See, I'm gonna minor in something random too, though. Like, I'm gonna major in like biochemistry, and then like minor in business management.
What?
It's really random.
That is.
I'm gonna have a restaurant, so I gotta.
In Florida Tech, there's this, my tour guide, she was like,
What are you gonna
Yeah.
do with the biochemistry then?
she's like,
I'm gonna be like a geneticist.
she was like, I'm a biochemistry major and my minor is AI studies. And I was like, okay.
It's like the Snapchat thing that's like super creepy.
Okay, that thing
Oh
gets
my
really
gosh.
creepy.
I've
Holly.
had-
I'm like, how do I unfriend this?
I've had it for
Think
a
it's
long
time to
time.
delete
I didn't know
Snap.
it was new.
I think it's time to delete Snap.
Well,
That
it
seems a
still
little
haven't gotten
sketchy.
Holly had it like before everyone else.
Yeah,
always,
me
though.
too. I think it's a Snapchat premium thing. I don't know why I have Snapchat premium, but
Holly has it for the background.
yeah. I like the thing, like the little animation it shows me when I record a video. I think that's why.
Yeah.
But it is a little creepy, I'm not gonna lie. But my friend,
What is
like,
happening?
probably the middle schoolers, he had it like write an essay. It was like write a 8-paragraph essay about like,
Wait,
the
it
color.
actually will?
yeah, it did. But I think
There's gotta be some plagiarism in there.
yeah, probably. And now they have like, for turn it in for like college and stuff, they have like AI detection tools.
This
Because
way you
people
can
use, we're using that like
ChatGPT.
chat GP,
Chat
whatever.
GPT, yeah.
Mhm.
That's kind of smart though, if you think about it.
It's 8th grade.
No, imagine like your doctor did all their essays on chat GPT,
my
so
brother's
she doesn't
class.
even.
She doesn't
they
even know how to treat you.
Be like, this wasn't on the Quizlet.
Not surprised.
That's our
Oh, wait,
future
are you looking
doctors
at them
for
through like the cameras?
There's a camera. There's cameras.
Yeah, there's also cameras.
Cameras
on
everywhere.
Where are they?
Oh, that's
Everywhere.
And there's some that can't be seen.
Oh yeah.
Really?
Did they put cameras in the classrooms?
No.
No, I don't think.
But
Is there a camera in this room?
I just said they're not in the
They're not in the
classrooms.
classroom.
However,
You just
technically
walked in
speaking,
with-
there is a camera in the classroom because I'm recording this. But,
Probably a few cameras in here.
Hello, world.
you know, definitely. All right, everybody have this table ready to go?
Yes.
Okay, cool.
My lines are just way bad.
All right. I'm gonna use a different color again just
I wonder where
because
Maddie is. I'm really hungry.
I want to actually be able to see this. Well, if they ordered for like everyone, then it's probably taking
Most everybody
forever.
mobile ordered though.
Oh, okay.
Excuses.
All right,
I'm
so the
just here.
subintervals are going to just be what these base lengths are. So like 0 to 1/2, 1/2 to 1. So I'm going to go through and go ahead and write all of those first.
Do you understand?
I understand that.
Oh wait, do I?
You're just putting the thingies in there. It's not.
I do understand. Sorry, Peyton. It was too. Hold up.
And so if the subintervals are like 0 to 1/2, what does that mean the base has to be? The base length.
Half.
Yes. All the way down, it's 1/2.
Oh, dang it. I put one.
Did you miss one?
No, I just put an extra.
The other day when I was doing this, I left one out altogether, and I was like, well, that's nice. So I just had to wedge it in there somewhere.
No. That's the worst when you have like a beautiful table and then you just have to like squeeze
Dang
it
it.
through in there.
That's why I waited. I was like, let her write it first, and then
Yeah.
I'm gonna copy it down.
I
and
don't
she
draw
does
any of the
columns.
lines
Yeah.
until
Yeah,
I'm
me
like
too.
done writing.
It's not fair. Your tablet just makes the line straight for you.
Well, you have lined paper.
It does
Yeah.
not work. It does not work.
It doesn't work. When
You
put
could
the
get an
lines
iPad
in.
too.
That's
Wait,
sad.
let me see.
You're so
How's it
mean
not
to
work,
me.
Josh?
You're mean to me
It
too.
looks fine.
All right, so because we care about the right hand endpoint,
Use your ear.
I'm going to be taking f of 1/2 because that's the right hand endpoint. F of 1. F of
Putting in the box.
3/2, huh?
Is there something else we're putting in the box?
Yeah, work to go with it. I'm just going and labeling all of these first so that we can see what's happening. F of 5/2 and F of 3. Now, if we cared about left hand, then obviously we would be using 0, 1/2, 1, 3/2, 2, and
Oh, I
5/2.
see.
But we're doing right hand, so that's why we get the right hand point. So then we're plugging in. Okay, remember it's f of x is equal to x squared. So we're plugging in those numbers for x. So it'll be 1/2 squared, 1 squared, and so on and so forth.
Wait, can you repeat that?
So we're plugging in y.
So we're plugging in 1/2. So like for x. So the function is f of x is equal to x squared. So anywhere there's an x, we're replacing it with the number.
Oh.
So this would be like 1/2 squared, and that would be equal to 1/4. Then 1 squared, which is 1. 3/2 squared, which is 9/4. 2 squared, which is 4. 5/2 squared, which is 25/4. And 3 squared, which is 9.
Why is there so many of them?
So many what?
Do they not add?
Children.
Do they not add this
They
camera
sound
in there?
so loud.
Probably
There's
not.
8 of them in there.
They probably don't know.
Is there a
It's
teacher
the
in there?
loudest one.
I don't see one.
They're like, Zach, I know how to do it.
Can you see the camera that's in the computer?
Mm-hmm.
I think that's what she's
You can
looking
see
at.
all the
It's
cameras.
very obvious.
Yeah.
But part of the reason is because I'm responsible for that room if something happens.
Right.
Like if there's like a fire or an
Or like a
intruder or whatever,
lockdown.
I have to. So it's nice to be able to see like, do I need to go in there and actually check, or can I just?
Pull up the camera. No one's in there. Okay.
No one's in there. I'm good.
Okay.
Unless
Unless
they're,
somebody's
like,
hiding under one of
hiding.
the desks.
That was
Like, I don't know.
Oh.
Well-
No, they probably hide like under the computer lab. Like under the
Really?
desk, but like this way on this wall.
Yeah.
But I can always look at the playback and see if they left. So if there was somebody in there to begin with. Okay, so now area. Well, area would be for a rectangle, length times width, so base times height in this situation. So 1/2 times 1/4. And, well, I'm going to do them as, I already have them written down, so I'm going to just do them as decimals. Just trust me on this, is 0.125. If you don't believe me, you can check them after. 1/2 times 1
Okay, I
is
believe the math major.
0.5.
Yeah.
I appreciate it. 1/2 times 9/4 is 1.125. 1/2 times 4 is 2. 1/2 times 25/4 is 3.125. And 1/2 times 9 is 4.5. So then if we add all these up, area is equal to 11.375. So this is the approximation for area under the curve from 0 to 3.
Yeah, it just took so long because we had to write out the problem.
There are shortcut ways to do this, but
But you gotta show.
but there's a lot that you have to know about calculus to do the shortcut way. So
Okay, yeah, so.
Still not us.
Yes, I know that.
Yeah, right.
well, I say that. We kind of will end up doing it the other way,
We're
but
gonna be calc experts by the end of this year.
At the end of this year, I don't know about.
you'll be very ready by this time next year.
Cool.
Yes.
So basically what we just found is this area down here. Okay, so this is a little bit of an overestimate because obviously we have some area that's above that we've included, which later we'll talk about if it's an overestimate, underestimate, and all this other stuff. But we're looking at specifically the area that's underneath the blue line from 0 to 3, or
Okay.
the blue curve. All right. The definite integral.
Integral.
No. That word. I just can't with that word.
Well, it's your shortcut method for that problem, so.
Yay.
Fine, I'll let it slide.
Oh, I'm so glad, Josh. Now we can
Yeah.
definitely go on.
You're under.
What? This is a long definition.
Huh.
1, 2, 3, 4, 5, 6, 7, 8, like 9 lines. So, let f be a function
Are you serious right
defined, but this is the last page, so.
now? No, I just ripped my
On-
notes out of my.
Oh. On the closed interval a to b, and okay. The summation from I is equal to 1 to n of f of x sub I, delta x,
Alright, I'm at
Stop
start.
it. Just stop it.
Bro,
be
what is-
defined as above, which I'm actually gonna write below.
Wait, what is killing me?
I'm gonna define that in a minute, so
Wait,
it's
this
gonna
is
be
not
below.
over.
That,
I'm mad I wrote the word summation because I thought it was meant to be a word.
No, it's a fancy E. It's really supposed to look like this, but that's a lot of work every time, so I just write it as like a sideways M. Then the definite integral of f over the closed interval a to b. So a definite integral has an interval that we're looking at it on. An indefinite integral will not have an interval. Okay, when we get there. Denoted the integral from a to b of f of x dx is given by the integral from a to b of f of x dx is equal to the limit as n approaches infinity of the summation of I is equal to 1 to n of f of x sub I delta x,
Okay.
provided the limit exists.
Makes sense. Okay, I got that part.
Right? That's the only thing that makes sense. I've seen this before though.
If the limit exists, we say
Not that.
not that, that's correct. F is integrable
That's a what?
on the closed interval a to b.
Math just be making up words these days.
How is it not a teacher there? I'm not.
Is that like
The
a
teacher is
schedule?
in there now.
Oh.
No.
They don't look like they're getting much work done, to be completely honest. But
Doesn't sound like it.
What is it?
it's either Spanish or English. I'm not really sure.
Definitely not Miss Patton.
It's probably
Well,
Spanish.
They don't have her.
But Spanish was first period.
Oh, well then I guess it's English.
Or maybe it's French.
Begin with, it's not. Continuous function. So this is the as defined below thing.
It's Miss Marshall's class.
Y is equal, no, it's not.
Oh, it's
It's
not?
8th grade. Y is equal to f of x over the closed interval a to b. Divide into n subintervals. So that's what we just had in the problem before, was all the little subintervals
Okay.
of length. Delta x is equal to b minus a over n. So that's basically how they broke up into the 6 subintervals before, was using this without actually telling you that's what was happening. That's the end of that definition, in case anybody wanted to know. We just have one example and then we're done for today, which is good because we have like 5 minutes left. And then tomorrow's all the examples.
Wow. I'm excited.
I really feel the excitement in my voice, Josh.
Yeah, you can hear it.
Are we still watching Hamilton? Did we
Yeah.
finish it?
We did not.
Yes.
We're on
Nate,
one last time. He said he was gonna restart the song.
have you given Mr. Holliger his review? I don't think we should take the
I cannot take that quiz today.
So that's what we're gonna say. To get out of the quiz. Well,
Because I haven't given.
I literally
I
cannot
haven't
take
given
that
him
quiz
mine
today.
either.
This is our last unit. It's fine.
yeah, and we're literally in no rush. Like, we literally have
Like book 3 still has like 3 units left.
I know, so.
All right, your example, computing an
How
integral.
long is this example?
Short.
Yeah.
Find the integral from 1 to 5 of 2x dx. It's so sad that there's a shortcut, but you don't get to do it yet.
But you said it's short.
It is short, but there's a shorter cut than what I'm getting ready to do.
That's
Yes. Isaiah. I like the
Thank you.
squiggle things, like the S.
Honestly, yeah, I kind of like that.
It's a fun part of the problem.
It's
What,
very
a squirrel?
satisfying.
It actually.
It's not a swirl. It's a.
It's an integral.
Yeah.
Basically, a squiggle.
Oh, I thought it was a big ass.
If you
Right.
squint your eyes.
Well, it kind of is.
Ew, that's a gross interval. Is that?
You'll get better at them, I promise.
Is it 2x?
Yes, 2x dx. This is the area under y is equal to 2x over the interval 1 to 5. Using the area formula, area is equal to height times base 1 plus base 2 over 2. Then we can take the integral from 1 to 5 of 2x dx, which is equal to, the height is the difference between 1 and 5, so that's going to be 4, times, then we plug in, excuse me, these numbers to this equation, so it's going to be on top 2 times 1 plus 2 times 5 divided by 2. And so then on top you have 2 plus 10 divided by 2. So 12 divided by 2 is 6 times 4 is 24. So the area under that curve is 24.
Oh.
Or technically speaking under that line. But super duper easy.